So thank you for showing up for your learning, and welcome to lesson 3.2, which is this is the fun part about math. So the more you learn, the easier it gets. Because now you're going to have multiple tools to do the same thing. Graphing a quadratic is going to give us a lot of possibilities for solving quadratic questions. And the quadratic formula is a powerful tool that we can use to graph these quadratics really accurately. And I think easily, because we're going to have multiple ways that we can do this now. So let's take a look. Suppose we want to graph this quadratic, 2x squared minus 2x minus 3. Now, first of all, we can find the roots of that quadratic equation with the quadratic formula. That's what the quadratic formula is for, is finding when is that quadratic touching the x-axis, when is its y value 0. So let's do our a, b, and c. So in this case, our a, we get that from here, it's 2. Our b is not 2, it's negative 2. So make sure you get that in there, correct? And then c is negative 3. So I completed a little chart to help me with my substitutions. And now I can get started on the quadratic formula. I know that x is going to be equal to, copy out the formula first, but I helped you out here by putting it in. Negative b is going to be negative 2. So that's my b value, plus or minus the square root of b squared, so negative 2 in brackets, squared, minus 4 times a, which is 2, times c, which is negative 3, all over 2a. That's going to be 4, but I'm going to write 2 times 2. Okay, and then when you draw your square root sign, try and draw it over the whole, all of those numbers that are getting square rooted. It helps add a lot of clarity to your work. Now, we process. We just chug these numbers through the quadratic formula. X is equal to 2 plus or minus the square root of negative 2 squared is 4. And then let's do negative 4 times 2 times negative 3. Negative 4 times 2 is negative 8. Negative 8 times negative 3 is positive 24. So we have 4 plus 24. Cool. All over 4. All right, let's go down one more line. X is equal to 2 plus or minus the square root of 28 over 4. And we can simplify that even more. 2, for our purposes, a decimal expansion of the square root of 28 is just fine, so go ahead and get your calculator. You don't need to know the square root of 28 by heart, but I do know that this number is going to be really close to 5, a little bit bigger than 5, but not quite. Cozy day. Took me a second. But not really close to 6. It's going to be like 5.17 or something like that. 5.3. Okay, I was pretty wrong. 5.3. 5.3 is going to be lots of decimal places there, over 4. And then this gives us the two values that x can be. So if we have 2 plus 5.3 over 4, let's write it out over here. X is equal to 7.3 over 4, or x is equal to 2 minus 5.3, that's negative 3.3 over 4. Okay. 7.3 over 4, we might want to know what that is, so we just punch it in, 7.3, clear, so 7.3 divided by 4, it's going to be a little less than 2, is 1.825, okay, so we get a decimal number for that, 1.825, okay, and then this one, negative that, well, I bet it's going to be negative 0.825 or something like that, let's see, 3.3, but it's negative, divided by 4 equals negative 8.25, negative 0.825. Circle those. They're the important things we were digging out of the quadratic formula, and go ahead and plot them. Here's 1. Here is 1.5. Here is 1.825. Very close to 2. Okay, so we can label that point as well. We know it's one of the roots. it has an x value of 1.825 and a y value of 0. Not so bad. It's nearly 2. And then the negative 0.825, well, that's nearly negative 1. So we'll put it right there. Negative 0.825, comma 0. Okay, cool. My parabola is going to go through that, but who cares? All right. Now we've got the roots. We can also find another point really easily. We can find the y-intercept. We don't need the quadratic formula to find this one. We just input 0 into the function. Or we just read the c value. The c value here is minus 3, so I know the y-intercept is minus 3. But I can also find that if I really forget this trick of just reading c by inputting 0 in for x into this function. So here I would have 2 times 0, which is 0, minus 2 times 0, which is going to be minus 0, minus 3. So f at 0, when x is 0, this function is equal to minus 3. Shouldn't surprise us because that's the c value. So we can plot that one as well. That's down here. Boop. But it's not the vertex. It's just the y-intercept. And so how can we find this vertex? Well, 1/2 of the quadratic formula is just that first part, negative b. And it's still divided by 2a. And with negative b, we go plus or minus something. We go the same distance from negative b over 2a with the two roots. That first part of the quadratic formula is actually giving you the x value of the vertex. It's telling you the equation of the axis of symmetry. So this is the formula for the axis of symmetry. If you recognize that that's this part of the quadratic formula before we plus or minus something, then that will show you where the middle of your parabola is. And then you go plus minus from that. So let's take a look. In this case, our a is 2 and our b is 2, negative 2. So if a is 2 and b is negative 2, we can solve this little mini equation. Come on, zoom. There we go. So here we go. X is equal to negative b over 2a. Well, that was easy. That was a very short song. Doesn't really have the same hit potential. Oh, wait, but the 2a, it's 2 times 2 because a is 2. Okay, so negative 2 over 2 times 2, that's equal to 2 over 4. That's equal to 1/2. Okay, 1/2 is the x value of the vertex. So we want to graph this vertical line on our sheet, and you can do it as a dotted line. I'm going to grab a different color here to do this. It's not going to be part of my parabola. It's a different thing. And so I go in here, and I want to find this line x is equal to 1/2. So here's x is equal to 2. Here's x is equal to 1. Here is 1/2 right there. Boop. And so I'm going to go up here, and draw a little dotted line for the axis of symmetry, and down there. All right. And then I can even label it x is equal to 1 over 2. So that's the axis of symmetry. I know the vertex is going to be somewhere down here. But exactly where? Let's find out. So this is really valuable information because if you know the x value of the vertex, you can just put that value into the function to find out the y value. And let's do exactly that. So we have f of x is equal to this. We know that the x value of the vertex is 1/2. So we're going to substitute that in for x wherever we see it. 1 over 2 squared minus 2 times 1 over 2 minus 3. And then we evaluate. The first thing that we do is the exponent. So 1/2 times 1/2. Half of a half is a quarter. So that's a 1 over 4. You just square the top and square the bottom. So we have 2 times 1 over 4 minus 2 times a half. Well, half of 2 is 1, so this is negative 1 minus 3. Okay. 2 times a quarter, well, that's 1/2. So we have this is equal to 1/2 minus 4. 1/2 minus 4, well, that's negative 3.5. Or, if you prefer, we could have gone over here and said 1 over 2 minus 8 over 2. 8 over 2 is 4 written another way. And then we would see that that's equal to negative 7 over 2, which is the same thing as negative 3/2. My mind thinks negative 3 halves because I go minus 4 and then up a half, so it's negative 3 halves. So now let's take that. The significance of this is that when the function, when we let x equal 1 half, it outputs negative 3 halves. So we know that's the y value of the vertex. Therefore, the vertex is 1 half, negative 3 and 1 half. Or negative 3.5 if you prefer. Go ahead and plot it. There's my 1 half. It's already that line. Here's 3. Here's minus 3. Here's minus 4. Here is minus 3.5. And then, by symmetry, I know that that point is on the parabola, and I can graph the whole thing. Whee! And so on. And then whee! And it goes through that point, and then up. Just like that. Now this is how you can use a quadratic formula to find important points about your quadratic, like the roots. The y-intercept is right there if you've already got it in standard form. It's just the c value. And if you forget, put in 0 for x and find out what it equals. It will equal the c value. And then to find the vertex, you use a little part of the quadratic formula, negative b over 2a, and that gives you the middle of the quadratic. Put the value that you find in for x, and it will tell you the y value of the vertex, and you're good. So flip it over, and you all try these examples. Try this one. G of x is equal to that. See if you can get a good graph of it over there, extracting your a, b, and c from here, using the quadratic formula, and then finding the axis of symmetry, find the vertex, and then try this one. After you're done those two, show them to me, and then you can also grab the whiteboards. We have new graphing whiteboards, and try graphing the quadratics that are on page 133, number 11. Maybe I'll take a picture and put it onto I could have taken a picture and put it on the sheet. Oh well, next time I'll remember to do that, because not everyone brings their textbooks. Any questions, hit me up by email. Otherwise, thanks for showing up for your learning.